Taking a look today at a problem from Chapter 5, Section 7. We're looking at the artillery problem. It's problem 5 on page 212. And we have the artillerymen are trying to, on a hillside trying to hit a target behind a mountain on the other side of a river. They have their own position at 250, where x is the kilometers and y is the number of meters of elevation. Their target is located at -2, 50. In order to hit the mountain, in order to avoid hitting the mountain, they need to go through a specific point that they have already calculated. Now, we can write this particular equation for the parabolic path of the projectile. The way to do that is we have 3 points. So you have 3 points. We have -2, 50, -1, 410, and we have 3, 250. If you have a calculator, you can go ahead and do quadratic regression right now, or we can go ahead and set up a system of equations using doing this by hand. So we know it's going to end up being y equals ax squared plus bx plus c, so we can go plug in our xy's to get ourselves 3 equations. So we have 50 equals 4a minus 2b plus c, and 410 equals a minus b plus c, and then we have 250 equals 9a plus 3b plus c. We can go ahead and solve this. My first equation, I'm going to take this equation and subtract away this equation. So that will give us -360, and then equals 4a minus a is equal to 3a, and then -2b minus b is -b. And the reason why we did this is because c minus c will cancel itself out. Next, I'm going to subtract this equation from this one, so it'll be, I paired up these first two first, and now I'll compare these two. So, actually, I'm going to take away, I'm going to let my coefficients over here be negative. I'm going to try to keep my variables positive, so I'll take this equation, and I'll subtract from it this equation. So 250 minus 410 is -160, and then we have a equals 8a, and then we have plus 4b. We could go ahead and multiply this equation by 4, but I can see that this equation has a greatest common factor of 4, so I'm going to divide by 4 on both sides. So it'll become the same as -40 equals 2a plus b, and I can carry down the -360 equals 3a minus b. When we combine those, we have -400 equals 5a. Gives us -80 for our a. We can go ahead and we can plug this back in a variety of places. I'm going to plug it in right here. So we have -40 equals -160 plus b, gives us our b being 120. I'm going to go ahead, I'm going to plug both of those in up here. So we have 410 equals our -80 from our a, and then we have -120 from our b plus c. This is -200. This gives us 610 as our c value. So our equation for part A is y equals -80 x squared plus 120x plus 610. Now it asks, how high above the river will the projectile be when it crosses the right river bank at x equals 2? X equals 2 is where the right river bank is. In order to find that, the height is being represented by y here. So if we replace x, we'll be able to find the y. So for part B, we can go ahead and replace this with 2. So y equals negative 80 times 4 plus, this is times 2, so we have 240 plus 610. This is negative 320, negative 80, so you have 530 meters is how high it is when we're at the right riverbank. For the left one, you just go ahead and you plug in 0, and that should be pretty quick for us. At that point, we have 610 meters. It says it wants to know approximately where the projectile will be when our y value is 130. So we can go ahead and we can replace our y value with 130 and see what the x would be. So we have 130 equals negative 80 x squared plus 120x plus 610. Now when we go ahead and solve this, we can do quadratic formula. I'm about to start running out of time because the bell's about to ring. But my advice would be to do quadratic formula at this moment. If I was going to be doing it by hand, I would have divided by 10 on both sides first to make it easier to do. And then divided by 4 as well, because I see another factor there, negative 2x squared plus 3x plus 12, and then solves with the quadratic formula on my own. The last one I really want to talk about quickly, because I know you guys know how to do quadratic formula. The reconnaissance plane flying at 660 meters. It wants to know if it's in the danger of being hit. In order to be able to know whether it's in danger, you have to see if it's possible to go that high. So you either plug in 660 and use the discriminant, or you could go ahead and find the vertex and see if it went that high.